First question, an e-commerce company runs its web application on EC2 instances in an autoscaling group, and it's configured to handle consumer orders in an SQS queue for downstream processing. The DevOps team has observed that the performance of the application goes down in case of a sudden spike in orders received. As a solutions architect, which of the following solutions would you recommend to address the use case? Your four options. This is your option 1, this is your option 2, this is option 3, and this is option 4. Got it? You have 10 seconds time to answer the question, and your time starts now. Time up. Now let us analyze the answers. Option 2, use a simple scaling policy based on a custom Amazon SQS queue metric. This option is incorrect because a simple scaling policy is too basic for this use case. It would only add or remove instances based on a single threshold, which might not be enough to handle sudden spikes. So option number 2 is the wrong answer. Option 3, use a scheduled scaling policy based on a custom Amazon SQS queue metric. This option is also incorrect because a scheduled scaling policy is based on a fixed schedule, not the actual workload. This wouldn't help to handle sudden unpredictable spikes in orders. So option number 3 is also the wrong answer. Option 4, use a step scaling policy based on a custom Amazon SQS queue metric. Also incorrect because a step scaling policy is similar to a simple scaling policy but with more thresholds. However, it's still not effective as a target tracking policy in handling sudden spikes. Okay, so option number 4 is also the wrong answer. Option number 1, use a target tracking scaling policy based on a custom Amazon SQS queue metric. This option is correct because a target tracking scaling policy based on custom Amazon SQS queue metric is the best solution. This policy allows auto scaling to adjust the number of EC2 instances based on the queue length, ensuring the application can handle sudden spikes in orders. This is why option number 1 is the correct answer. Got it? Let us move to the next question. A company has many VPC in various accounts that need to be connected in a star network with one another and connected with on-premises networks through direct contact. What would you recommend? So this is option 1, this is option 2, option 3, and option 4. You have 10 seconds time to answer the question, and your time starts now. Time up. Now let us analyze the answers. Option 2, private link, is incorrect as AWS private link is a service that enables private connectivity between VPCs, AWS services, and on-premises applications. While it provides private connectivity, it's not designed for connecting multiple VPCs in a star network. Okay, so option number 2 is the wrong answer. Option 3, VPN gateway, this also is incorrect. VPN gateway is used to create a secure encrypted connection between your VPC and your on-premises network. While it provides connectivity, it's not designed for connecting multiple VPCs in a star network. Okay, so option number 3 is also the wrong answer. Option 4, VPC peering. VPC peering is also incorrect as it is a networking connection between two VPCs. It allows connectivity between VPCs, but it's not designed for connecting multiple VPCs in a star network and can become a complex thing to manage. Okay, so option number 4 is the wrong answer. Option 1, transit gateway, is correct because AWS transit gateway, it's like network hub that connects multiple VPCs, VPN connections, and direct connections in a star network. So it's like designed for this exact use case, and it makes it easy to manage and scale. Okay, so option number 1 is the correct answer. Got it? Let us move to the next question. An Amazon EC2 instance is generating very high packets per second and performance of the application stack is being impacted, right? A solutions architect needs to determine a resolution to the to this issue that results in improved performance. Which action should the architect take? So you have again 4 options. This is option 1, this is option 2, this is option 3, and this is option 4. Okay, your 10-second timer starts now. Time up. Now let us analyze the answers. Option 1, configure a RAID 1 array from multiple EBS volumes. This option is incorrect, as configuring a RAID 1 array from multiple EBS volumes would provide redundancy and improve storage performance, but it wouldn't directly address the high packets per second issue impacting the application stack. So option number 1 is the wrong answer. Option 2, create a placement group and put the EC2 instance in it. This option is also incorrect, because creating a placement group and putting the EC2 instance in it would help optimize network performance by reducing latency and jitter. However, not the most direct solution to address the high packets per second issue. Okay, so option number 2 is the wrong answer. Option 3, add multiple elastic IP addresses to this instance. This option is also incorrect, because adding multiple elastic IP addresses to the instance wouldn't improve the performance. Elastic IP addresses are used for external connectivity, not for improving network performance. Okay, so option number 3 is the wrong answer. Option 4, use enhanced networking. This option is correct, because using enhanced networking would significantly improve the performance of the application stack. Enhanced networking provides higher packet processing rates, lower latency, and improved overall network performance, making it the best solution to address the high packets per second issue. Okay, so option number 4 is the correct answer for this question. Okay, now let us move to the next question. A retail company wants to roll out and test a blue-green deployment for its global application in the next 48 hours. Most of the customers use mobile phones which are prone to DNS caching. The company has only 2 days left for the annual Thanksgiving sale to the comments. As a solutions architect, which of the following options would you recommend to test the deployment on as many users possible in the given time frame? So you have again 4 options. This is option 1. This is option 2, this is option 3, and this is option 4. Your 10-second timer starts now. Time up. Now let us analyze the answers. Option 1, use AWS code deploy deployment options to choose the right deployment. This option is wrong, as AWS code deploy helps automate deployments, including the blue-green deployments. However, it does not control how traffic is routed to the new or old deployment, which is what the question focuses on. This option is irrelevant, because it doesn't address the issue of testing on real users or handling DNS caching. Okay, so option number 1 is the wrong answer. Option 2, use elastic load balancer to distribute traffic across deployments. This option is also wrong, because ELB can distribute traffic across different instances or deployments. However, ELB cannot differentiate between blue and green environments automatically in a way that supports gradual testing. It also doesn't solve the issue of DNS caching on mobile phones. Okay, so option number 2 is also the wrong answer. Option 4, use Route 53 weighted routing to spread traffic across different deployments. This option is also wrong, because Route 53 weighted routing allows traffic to be split between deployments by assigning weights to DNS records. However, due to DNS caching on mobile devices, changes to DNS records might not propagate quickly. This makes it unsuitable for testing deployments in a short time frame, like 48 hours. So option number 4 is also the wrong answer. Option 3, use AWS Global Accelerator to provide to distribute a portion of traffic to a particular deployment. This option is correct, because AWS Global Accelerator uses static IP addresses instead of DNS names, which solves the problem of DNS caching on mobile phones. It can direct a portion of user traffic to the blue or green deployment, allowing for a controlled rollout. This ensures that even mobile users with cached DNS records can be routed correctly, making it the most effective solution for this situation. Okay, so option number 3 is the correct answer. Okay, let us move to the next question. This is going to be our last question for this video. Okay, an elastic load balancer ELB has marked all the EC2 instances in the target group as unhealthy. Surprisingly, when a developer enters the IP address of the EC2 instances in the web browser, he can access the website. What could be the reason for the instances being marked as unhealthy? You have to select two options. Okay, this is your option 1, this is your option 2, this is your option 3, this is your option 4, and option 5 is this one. So it is a bit problematic. Just for a little one line, it's not fitting. This is why if you need some more time to navigate through the options and all, you can take some more time, because we are going to follow the standard timer 10 seconds itself. Okay, the time starts now. Time up. Now let us analyze the answers. So option 1, your web app your web app has a runtime that is not supported by the application load balancer. This option is incorrect, because the web app's runtime is being unsupported by the application load balancer, and this wouldn't cause the instances to be marked as unhealthy. The ALB would still be able to send health checks. Okay, so option number 1 is the wrong answer. Option 4, okay, the EBS volumes have been improperly mounted. This option is also incorrect, because improperly mounted EBS volumes might cause issues with the instances, but it wouldn't directly cause the ALB to mark them as unhealthy. Okay, so option number 4 is the wrong answer. Option 5, you need to attach elastic IP to the EC2 instance. This option is incorrect, because attaching an elastic IP to the EC2 instance isn't necessary for the ALB to send health checks. Okay, so option number 5 is also the wrong answer. Option number 5 is the wrong answer. Option 2, the route for the health check is misconfigured. This option is correct, because if the route for the health check is misconfigured, the ALB might not be able to reach the instances, causing them to be marked as unhealthy. So this is the right answer. One right answer. Another one is the security group of the EC2 instances does not allow for the traffic from the security group of the application load balancer. This option is correct, because if the security group of the EC2 instance doesn't allow traffic from the security group of the application load balancer, the ALB's health checks would fail, causing the instances to be marked as unhealthy. Got it? This is why option number 2 and option number 3 are the correct answers, and option number 1, 4 and 5 are the wrong answers. Congratulations for successfully answering 5 questions today. Please make sure to like this video if you really enjoyed like the questions, and subscribe to AMG Cloud for more videos like these. We even have a separate playlist for AWS Cloud Practitioner and separate one for AWS Solutions Architect, so you can go visit if you want to practice some questions. Okay, that's it for today's video. I'll meet you in the next video with a new set of questions. Till then, keep learning, keep practicing and keep exploring. Thank you and bye-bye.